Hello everyone. Today we're gonna talk differential equations, particularly those equations involving homogeneous coefficients. So the differential equation is in the form m of xy dx plus n xy dy is equal to 0. It is said to be homogeneous if both m and n functions are of the same degree. So the following theorem explains the homogeneous equation. So the function is said to be homogeneous of the same degree k in xy if and only if the function lambda x lambda y is equal to lambda to the k of the function f x and y. So polynomials in which all terms are the same degree, such as this one, f of xy is equal to 2x squared plus 4xy plus y squared. G of xy is equal to x cubed y plus 2x y cubed. And t of xy is equal to x to the fourth y plus 7y to the fifth. They are called homogeneous polynomials. Why? If you try to add the exponents of each variable in each term, they are all equal. For example, the first equation, f of xy is equal to 2x squared plus 4xy plus y squared. It has a degree 2. Same with the other one. The g of xy is equal to x cubed y plus 2xy cubed. It has a degree 4. And the other one, t of xy is equal to x to the fourth y plus 7y to the fifth. It has a degree 5. Okay? So, these are some steps in solving homogeneous equations. Number 1, you try to look, can the variable be separated? If yes, you just do the separation of variables. And then, if not, verify that the differential equation is homogeneous. And then if yes, let y is equal to vx or x is equal to vy, depending on which variable is simpler. The number 4, you have to solve this differential equation by separation of variables after substituting it to the function. And then after that, let v is equal to y over x or v is equal to x over y, whichever you substituted earlier. So let's take a look on the following examples. Okay, as an example, if we have here a problem 2 multiplied by the quantity 2x squared plus y squared dx minus xy dy is equal to 0, the first thing we have to look into is, can the variables be separated? If yes, just do the separation of variables. But in this particular problem, it's not. So let's take a look on its degree. Looking into this problem, they have the same degree, right? So the degree is 2. So this is a homogeneous equation. Now, the next thing we have to do is, we have to take a look which one is simpler. In this particular problem, the simpler one is y, right? So we put it as y is equal to vx such that dy is equal to v dx plus x dv. Notice, guys, what if we put x is equal to vy? What will happen? You'll notice our dx is equal to v dy plus y dv. which is if we try to substitute dx in here, what will happen? We will be multiplying two terms in here, um, which makes the problem harder to solve. Wherein if we try to substitute dy in here, it's just simpler because we are just only multiplying one term to this one. So in this particular problem, we will use y is equal to vx. Then let's proceed. So we have to substitute y in the problem. So we have 2, okay, 2x squared plus, what is our y? We substitute it. So we have v squared multiplied by x squared, and then dx minus xy, okay, and then what is our dy? Our dy is v dx, sorry, we have to substitute y in here. So that will be vx, right? So vx, and then v dx plus x dv, and that is equal to 0. Okay, now we'll do the algebra. So we have to factor out x squared in here. So we have 2x squared, so we have 2 plus v squared dx minus, same is true with here. So we have x squared v, and then v dx plus x dv, and that is equal to 0. So we can eliminate x squared in here by dividing 1 over x squared on all. So if we try to divide x squared in here, 0 over x squared is still 0. So and let's put it that way. Now, if we try to distribute that one, so we have 4 plus 2v squared, okay, dx minus v squared dx minus xv dv equals 0 by just multiplying these terms. Okay, now let's do the separation of variables, or let's simplify first dx together. So looking at this one, 2v squared minus v squared is just v squared. So therefore, we have 4 plus v squared dx minus xv dv is equal to 0. Now, looking at this one, the variables can already be separated. Okay, so let's just do the separation of variables. How do we do the separation of variables? Let's divide. If we try to divide, where is my cursor? We try to divide x and then 4 plus v squared, and then x 4 plus v squared on all sides. So notice x and x be eliminated, and this part, that is 4 plus v squared, is eliminated. Okay, so what will happen next? What happens is that we have dx over x minus v dv over 4 plus v squared. and that is equal to 0. Now, we'll try to integrate these terms. Okay. Try to integrate this problem. So dx over x, we have here ln of x minus, what's the integral of v dv over 4 plus v squared. If we put this one as our u, so 4 plus v squared, what is our derivative? So our derivative should be 2v dv. But look, if we try to look on this problem, there's no 2 in here, so we have a balance factor of 1/2 there. Okay, so now we have 1/2 ln of 4 plus v squared, and that is equal to, so the integral of 0 is a constant, so we can actually put it as ln of c, wherein ln of c is still a constant. Okay, so if we try to eliminate this 1/2 in here, we'll just have to multiply 2. Okay, so that will be 2 ln of x minus ln of 4 plus v squared, and that is equal to 2 ln of c is still c, so we put that as ln of c. Okay, in the properties of logarithm, we have ln n ln of x is equal to ln of x to the n, right? So we can actually put this one into ln of x squared minus ln of 4 plus v squared, and that is equal to ln of c. So in the properties of logarithm, if we have here ln of a minus ln of b is equal to ln of a over b, right? So this function, we can actually put that as ln of x squared over 4 plus v squared, and that is equal to ln of c. To cancel out to eliminate the ln, the logarithm part, we have to put e to the e in here, right? So you can still remember in properties of logarithm, we have e to the ln of x is equal to x, right? So therefore, we have here x squared over 4 plus v squared, and that is equal to c. Now, but what is we can simplify this further. If we try to simplify this further, we have here x squared is equal to c multiplied by 4 plus v squared. But what is v? Our v is equal to, let's go back to this problem. Okay, our v is equal to what? Y over x. So we have to substitute it in here. So our v is y over x, such that our x squared is equal to c, and then 4 plus y squared over x squared. Okay, so to simplify that further, we have here x squared is equal to c, and then for x squared plus y squared over x squared. Okay, and then we cross multiply that one, we have x to the fourth is equal to c for x squared plus y squared. So this is already our final answer. Okay, so let's take a look on a brief run through of this one. Okay, started from here, we have selected which we will use. So is it y or x? So we have seen that y is simpler. So we denote y is equal to vx, and then we substituted. After that, we substituted by algebraic manipulation, and then after substituting, we do the separation of variable method. Okay, so we arrive in this particular in this general solution rather. Okay, so that's one problem. Let's take a look on the other problem. Okay, let's take a look on this problem. If we have here 2y dx minus the quantity x squared plus 3y squared dy is equal to 0. So the first thing we have to do again is, can the variable be separated? In this particular problem, it's not. So let's take a look on its, if it is homogeneous. So if we have in this particular problem, it has the same degree. So this is a homogeneous. What is the degree? We have 2. Okay. And then, which is simpler, x or y? Looking into this one, x is simpler. So the previous problem, the simpler is y. So in this case, in this problem, x is simpler. So we put x is equal to vy, such that our dx is equal to v dy plus y dv. Then let's substitute to the problem. So here vy multiplied by y, and then what is our dx? Our dx is equal to v dy plus y dv. Okay, so plus y dv. Okay, minus v squared y squared plus 3y squared dy is equal to 0. And then let's do the algebra. So if here y squared v, okay, v dy plus y dv minus, let's factor out y squared there. So I have y squared v squared plus 3 dy equals 0. So let's eliminate y squared by dividing y squared on all. So y squared, such that now we have v squared dy plus vy dv Let's just distribute that one. Minus v squared dy minus 3 dy. Okay, so that is equal to 0. Okay. Let's arrange the terms. So notice v squared dy minus v squared dy is equal to 0. So this cancels out. Okay, therefore, what happened? So we have here vy dv minus 3 dy equals 0. Okay, now let's do the separation of variables. So we have v dv minus 3 dy over y, and that is equal to 0. Okay, so let's try to integrate this one. If we integrate this one, which we have here, okay, what's the integral of v dv? So we have v squared over 2 minus, in this case, the integral of 3 dy over y is 3 ln of y, and that is equal to, we can actually put that as ln of c. Okay, so now we try to eliminate 2 in here. We have to multiply 2 on all. Okay, or we can actually put that as v squared is equal, v squared over 2 equals, let's put this one on the other side. So we have ln of c, okay, plus 3 ln of y. Sorry. Okay, if we have here x squared y prime is equal to 4 x squared plus 7xy plus 2y squared. So in this particular problem, can the variable be separated? No, it's not. Okay, so what's the degree of this one? They have all the same degree, and that is 2. Okay, so this is a homogeneous function. Now, what is y prime? We know that y prime is equal to dy over dx, right? So we have to substitute it on the problem. So we have x squared and then dy over dx equals 4 x squared plus 7xy plus 2y squared. Okay, simplifying this equation, we have x squared dy is equal to 4 x squared plus xy plus 2y squared dx. In this differential equation, which is simpler? That's correct, y. So we put y is equal to vx such that our dy is equal to v dx plus plus x dv, rather, plus x dv. Now, if we try to substitute this one on our equation, so x squared, what is our dy? So we have v dx plus x dv equals x squared plus x, and then vx plus 2y squared, okay, and dx. Sorry, y squared should be v squared x squared, okay, v squared and then x squared, so dx. So we continue on. We have x squared and then v dx plus x dv equals, we can actually factor out x squared. Okay, so x squared, then we have 4 plus, sorry, we should have 7 in here. Okay, 7. So 7v plus 2v squared dx. Okay, so we can actually eliminate x squared on both sides by dividing 1 over x squared on both sides. So this can be eliminated. And then we have v dx plus x dv is equal to 4 plus 7v plus v squared and then dx. Sorry, there should be 2 in here. 2v squared rather. Okay, so what happened is that we have to put the x together. So we have here excuse me. So we have here x dv, right? So x dv, okay, we can put this dx on the other side. So we have 4, and then this one is positive. When we put it on the other side, will be negative. So that is 7 minus 1 is equal to 6. So 6 plus 6v plus 2v squared dx. Then we can put this on the other side. We have x dv minus 4 plus 6v plus 2v squared dx, and that is equal to 0. Okay, so this equation can already be separated. Okay, the variables can already be separated, but before we separate, we have to simplify this one. So we have x dv is equal to minus, let's bring out 2 in here. So we have 2 plus 3v excuse me, plus v squared dx. Okay, now it can be separated. So we have dv over 2 plus 3v plus v squared, right? Okay, minus 2 dx over x is equal to 0 by dividing on both sides x times 2 plus 3v plus v squared. Okay, so now what happened is that this particular problem, dv over 2 plus 3v plus v squared minus 2 dx over x is equal to 0. Now, we have to simplify this one by factoring this out. So dv over, in algebra, we can actually factor this out into v plus 1 and then v plus 2. Okay, minus 2 dx over x, and that is equal to 0. If we try to integrate each term, this term can be integrated by what? By partial fraction. Integration by partial fraction. So if we let 1 over v plus 1, okay, v plus 2 is equal to a over v plus 1 plus v over v plus 2. What happened? We have 1 is equal to a v plus 2 plus b v plus 1. Okay, so if we put if v is equal to -1 and we'll substitute it in here, what happens is that we will have a is equal to 1. Okay, if we put v is equal to -2 by partial fraction, we have b is equal to what? Substitute it in the function. We have -1. Okay, so therefore the integral of dv over v plus 1 v plus 2 equals what? We have dv over v plus 1 minus dv over v plus 2. So if we try to integrate everything, that will be, okay, we have ln of v plus 1 minus ln of v plus 2. Okay, so, or that is actually ln of v plus 1 over v plus 2. And so we substitute it on the function. We have ln of what? Ln of v plus 1 over v plus 2. Okay, what is the the integral of this one, we have 2 ln of x, right? Minus 2 ln of x, and that is equal to ln of c. Okay? Now, we will continue with our solution. So, we have here, okay? So, notice, in here we have ln of v plus 1 over v plus over v plus 2 minus 2 ln of x. The 2 ln of x can be transformed into what? So we have ln of v plus 1 over v plus 2. The 2 ln of x can be transformed into ln of x squared, and that is equal to ln of c. Now, again, by logarithm, ln of a minus ln of b, that will be, in this problem, we have v ln of v plus 1 over, this will become a denominator, so we have x squared, and then v plus 2, and that's equal to ln of, let's adjust the screen, okay, excuse me, ln of c. So, to eliminate the logarithm, so we have to put e in here, okay, such that it will be v plus 1 over x squared, v plus 2 is equal to c. Okay, so we can simplify this further into v plus 1 is equal to c x squared, and then v plus 2. But what is our v? Our v is equal to, but v is equal to y over x. So if we try to substitute on the solve function, we have y over x plus 1, okay, equals c x squared, and then y over x, okay, sorry, y over x plus 2. Okay, to simplify that further, we have y plus x over x is equal to cx squared, and then y plus 2x over x. So this can be eliminated such that our answer will be y plus x is equal to c x squared, and then y plus 2x. Okay, so finally, this is our final answer. And notice is the solution is quite long. Why? Because we know that integral calculus, in integral calculus, when it involves partial integration, partial fraction rather, yeah, it's quite a very long solution. So hopefully our sample problems help you in your lessons, particularly on homogeneous equation. See you on the next video. Thank you so much.